Okay, we are going to be looking at lesson 56 today, which is about angles of rotation. Okay, so let's say we have an angle like 135 degrees. Okay. So if we want to draw that in what's called the standard position, imagine you have your set of axes. This is the x-axis, this is the y-axis. So standard position. Okay, we have what's called the initial side. So we're going to take one of the sides of our angle and place it on the positive x-axis with the vertex on the origin. So we're going to put our vertex on the origin and one of the sides right on top of the x-axis. So we're going to put the vertex at the origin and then what's called the initial side in, oops, I'm missing an I, so initial side on positive x-axis. Okay, so imagine like here's one side of my angle, and then these are called angles of rotation because now I'm going to rotate. And now when the normal way that I rotate for an angle that's positive, like 135 degrees, is I rotate counterclockwise through the quadrants in order. So like this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So I'm going to go through them in that order. So I'm going to have my vertex at the origin, my side here, and then I'm going to rotate 135 degrees. So I'm rotating. I rotated 90. I rotated. Once I get to 135 degrees, I stop. And that is where I will put my terminal side. Okay. So let's say I'll put my terminal side here. Okay, and so this is 135 degrees. And okay, so that's 130. This is called the initial side. And this is called the terminal side. Okay, now in standard position, the initial side is always going to be on the x-axis, and then the terminal side is wherever it just happens to be when you stop rotating and get to the right number of degrees. So positive angles will always go through the quadrants in order. Now let's say I wanted to draw an angle of, let's say, negative 315 degrees. So if I do negative 315 degrees, okay, in standard position, so still I'm going to put my initial side on the x-axis, but this time because it's negative I'm going to rotate the other direction. So when it's positive I rotate, counterclockwise through the quadrants in order. If it's a negative number, I'm going to rotate clockwise in the opposite. I'm going to go through the quadrants in the opposite order. So 4, 3, 2, 1, I'm going to go backwards. Okay, so imagine I'm here. If I want to go to negative 315 degrees, I'm going to rotate in the negative direction. So I'll rotate, let's see, negative 90, negative 180, negative 270, negative 300, negative 315, and then I'll stop. Okay, and so that would be where my terminal side is going to be. So it will be right here. So I'm going to rotate this direction, negative 315 degrees. That's what my negative 315 degrees would be in standard position. Okay, so that gives us an idea of what angles look like in standard position. Now we could have some more kind of exciting angles. So let's say I want to do this angle 405 degrees and put that in standard position. Okay, well, 405 degrees, that's kind of big. You could never have that in a triangle or something like that, but it's still an angle and it's an amount that you could rotate. Right, so if I were to draw my axes and I put my initial side on the positive x-axis, I could certainly rotate 405 degrees. So I'd start here, I rotate 90, 180, 270, 360, and I keep going. 360, now I'm at maybe 400, 405. Okay, so I would stop right here. And so I went a full 360, and then I kept going and I stopped here. Okay, so this would be our 405 degrees. So let's say I wanted to do like negative 750 degrees. Okay. Yes, I can do that as well. Okay, so negative 750 degrees. Okay, I'm going to put my initial side on the positive x-axis. And then because it's negative, I'm going to rotate backwards. So I'm going to be going this direction, kind of clockwise. And I need to go 750 degrees. So let's see, one full turn would be 360. And then another full turn would be 720. So I'm almost there, but I need to go 720 and then a little bit more. Okay. And right here would be my negative 750. So there is, so what happened? I went 360, and then another 360 put me at 720. And then a little bit more, that will be at negative 750. Okay. So you can see that some of these angles that are bigger than 360 are somewhat, complicated to think about, and they're just like other angles. So we have this idea of what's called coterminal angles. So coterminal angles. So coterminal angles. Okay. These have the same initial and terminal sides. Okay. So, for example, let's think about this angle, angle right here. So I could find another angle that has this same initial side. Okay, this color is very close. Let me see if I can get it. So I have this same initial side right here, and then maybe I could just go like this and put my terminal side there. They'll line up, same initial side, same terminal side. Okay, how big is that angle? Let's see, this one went 360 and then another 45 to get there. So this would just be a positive 45 degrees. So that positive 45 is coterminal with the 405. So 45 is coterminal with 405 degrees. Okay. Or maybe I could do something else. Okay. Maybe I could put my initial side here, and then I could rotate backwards this direction, and then put my terminal side here. Again, same initial side, same terminal side. But what's that angle? Okay, well, if I had to rotate backwards, I would stop 45 degrees shy of 360, so that's at negative 315 degrees. Okay, so negative 315 degrees is also coterminal with 405 degrees. Okay, and so hopefully you can see a very easy way to find coterminal angles is just to add 360 or to subtract 360 to figure out, and just keep doing that over like multiples of 360, okay, to get to a place where you're going to have the same. It's just adding an extra rotation either forward, adding 360, or adding extra rotations backwards by subtracting 360. Okay, so that's what coterminal angles are. And often we'll want to talk about coterminal angles, okay, between 0 and 360 that don't rotate round and round and round and round and round. Okay. And in particular, there are angles, sometimes they're coterminal, sometimes they're not. But in trigonometry, angles that are very important to us are called reference angles. Okay, so reference angles, okay, are the acute angle, okay, made between the terminal side of an angle and the x-axis. Okay. So let's choose some angles. So for example, okay, let's look at 300, or let's do negative 340 degrees. Okay, we'll draw that in standard position, and then let's find what's called the reference angle. So I'll draw my axes. Okay, so I'm going to put my initial side always on the positive x-axis. Okay, and then because it's negative, I'm going to rotate backwards. So I'm going to go through the quadrants in the opposite order, 4, 3. Okay, so I'm going to rotate. I've rotated 90, 180, 270. And then before I get to the negative 360, I need to stop. So I'll kind of stop right there and put my terminal side. So this is my negative 340 degrees. Okay. And so in order to find a reference angle, okay, I want to take the terminal side, and find the acute angle that would be made with the x-axis. So here's the whole x-axis. Okay, and so, you know, this angle right here that it makes with the x-axis is not acute, but this angle right here that it makes with the x-axis, so this angle right here, this is my reference angle. Because that one's acute, and it's made with the x-axis. And so, what is that angle? And it's always going to be a positive number. We're not really going to use negative numbers when we talk about reference angles. So this reference angle right here is, well, let's see, net 340 degrees is 20 degrees shy of 360, right? If we went the whole way around, we would have 360. So this angle right here is 20 degrees. So 20 degrees would be the reference angle for that negative 340. So it's the acute angle made with the x-axis. Let's try a few more of those. So let's say we had 150 degrees. Okay. Let's find the reference angle. Okay, so if we put that in standard position, okay, here's our initial side, and then when we turn, we'll go 90, and we got to stop before we get to 180. All right, so we're going to stop. Our terminal side will be right here. Okay, so there's our 150 degrees. And if I want the reference angle, we'll have to look at the terminal side. Here's my terminal side. And what is the acute angle that's made with the x-axis? So here's the x-axis. The angle with this part of that's obtuse, so we're talking about this angle in here. That's our reference angle. Okay. And what is the measure of that? Well, if a straight line is 180 degrees, we went 50, we need 30 more degrees to make it add up. So that reference angle is 30 degrees. So the reference angle is 30 degrees here. Okay, let's try, let's do another negative one. So let's do negative 260. So let's try negative 260 degrees. Okay, I put my positive, my initial side on the positive x-axis, and then I'm going to rotate negative. So I'm going to rotate 90, 180, and just before I get to 270, I'm going to stop. Okay, so I'm going to stop right here. That's going to be my terminal side. So there's my negative 260. Okay. Now, sometimes this can be, because I mean, like, it was kind of keeping track of 90, 180, oh, I almost got to 270. Sometimes it can be easy to think, oh, the reference angle is this angle in here. Okay, I stopped 10 degrees before 270. But let's look at the definition. It's the acute angle made between the terminal side and the x-axis, not the y-axis. Never, ever, ever go to the y-axis. It has to be the x-axis. So here is my terminal side. I don't want to go to the y-axis. I have to go to the x-axis. So it's got to be over here. It's going to be this angle right here. Okay. So this one, okay, well, I went to 180, and after 180, I went another 80 degrees. So this is 80 degrees. My reference angle is 80 degrees. That's still an acute angle, but it has to be made with the x-axis, always the x. Okay. Let's try one more, I guess. Let's do 300 degrees. I've got room for one more. So 300 degrees, I'm going to put my initial side. This is positive, so I'm going to rotate 90, 180, 270, and then a little bit more and stop there. Okay, so my terminal side will be right here. So there's my 300 degrees. And in terms of the reference angle, I need to take my terminal side, which is here, and the acute angle made with the x-axis. That's this angle in here with the x-axis. So notice with these angles, sometimes you're going to go to the positive x-axis like we did with these two. And sometimes you're going to go to the negative part of the x-axis like we do with these two. It just kind of depends where you are. But it's always made with the x-axis, but it has to be the acute angle made with the x-axis. So here, let's see, we went 300 degrees, 60 more, and we would have done a full circle. So this is a 60-degree reference angle. Okay. So notice there's a difference between reference angles and coterminal angles. Coterminal angles always have the same initial and terminal side. Not true with reference angles. Okay. So sure, they don't even always, the reference angle doesn't even always have a start on the positive x-axis. Like if you think about these reference angles, there's no side on the positive x-axis. It's simply an acute angle between the terminal side and the x-axis, but it might be the negative side of the x-axis. So don't confuse these reference angles and coterminal angles. Okay. So the last thing that we want to look at in this lesson is sometimes we want to find the sine, cosine, tangent, cotangent, cosecant, whatever, for various angles, and all we know is a point on the terminal side. So let's say we want to find the 6 trig functions for the angle with, let's say, the point -3, 4 on the terminal side. Okay. So if we draw ourselves a picture, okay. So we're going to go to the point -3, 4. So -3 is here. And 4 is here, so the point -3, 4 is here. Okay. Our initial side is always on the positive x-axis, and then the terminal side is going to go through this point. Okay, so we need the terminal side to go through that point. And now I've got this angle. I'm not really sure what this angle is. Okay, I'm just going to call this angle theta. Okay. But I do know that I want to find the sine of theta and the cosine of theta and the tangent of theta and the cotangent of theta and the secant of theta and the cosecant of theta. Okay, I want to find all of those. So how would I go about doing that? Okay. So it's going to be, we're always going to use the reference angle. So the reference angle, we know we need the terminal side. And let's take the terminal side and then stop at the point that they gave us. Okay, and then where is our reference angle? Our reference angle is between the terminal side and the x-axis. So the acute angle between the terminal side and the x-axis is going to be this angle right here. Okay, and we'll take that angle and stop it, okay, at the coordinate -3, and then drop a perpendicular so I have a right triangle. So if I have a right triangle, then I can just use SOHCAHTOA to find sine, cosine, tangent, etc. Okay. And then we'll go ahead and label these, and we can use this reference angle, okay, and we can do the sine of the reference angle, the cosine of the reference angle, the tangents of the reference angle, and we can use this reference angle in the triangle as long as we keep the correct sign on all the sides. So normally you think, oh, triangles can't have negative lengths of sides. But in this particular situation, because we're positioning them on the coordinate plane, we will have some, maybe have some legs that have negative lengths. So for instance, this leg right here, because it goes along the negative x-axis, its length will be -3. Now this leg right here is going toward, along the positive y-axis, so this will be a +4, and the hypotenuse is always a positive number. The hypotenuse is always positive. So this is like a 3, 4, 5 triangle. Okay, notice the hypotenuse is always positive. Okay, only the legs will have signs, positive. Okay. And so now, once we've labeled that, we can easily find the sine, cosine, tangent by looking at the reference angle. Okay, and as long as we put the correct signs in there, use these values that I've written in green as our, this will be the opposite, this will be the adjacent, this will be the hypotenuse. So sine of theta will be the same as the sine of the reference angle in the green triangle that I drew, which is going to be opposite 4 over hypotenuse 5. So this will be 4/5. The cosine will be adjacent -3 over hypotenuse of 5. The tangent will be opposite over adjacent, so 4 over -3, or -4/3. I didn't really leave myself enough room to write these. Okay, cotangent. Cotangent is the reciprocal of tangent, so we'll just take the reciprocal of tangent, so that'll be -3/4. Secant is the reciprocal of cosine, right? Secant is the reciprocal of cosine, so that will be -5/3. And cosecant is the reciprocal of sine. Hopefully you remember that. So that reciprocal will be 5/4. Okay. Let's try another one of those. Okay. This time, let's find the 6 trig functions, and our terminal side is, okay, the point on the terminal side is going to be -15, -8. Okay, so we're going to go out, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's -15, and then -8. 1, 2, 3, 4, 5, 6, 7, 8. There's our -8. Okay, so there's our point. Okay, our initial side is always on the positive x-axis. Our terminal side is going through the point -15, -8. Okay, so there is our angle. Our angle is theta. Don't know what it is, but there it is. Okay, if I want to find sine, cosine, tangent, etc. for it, okay, I'm going to take the terminal side, but I'm going to just stop it at the point that's on it. Okay. And then think about where the reference angle is. Well, the reference angle is between, that side and the x-axis. So here is the reference angle that's between the terminal side and the x-axis. And I'm going to stop that side, okay, at the coordinate on the x-axis that'll make that a right triangle. Okay, so here's my reference angle right in here. Again, I don't know what it is, but all I need is to know the side lengths basically in order to be figure out the sine, cosine, tangent. Okay, and so this goes in a negative direction. So this is negative 15. Okay, this side also goes in a negative direction. So this is negative 8. And then if you know your Pythagorean triples, 8, 15, 17, then we know that the hypotenuse is 17. Hypotenuse will always be a positive number. And so now if I need to find the sine, cosine, tangent, etc., so the sine of theta, okay, I'm just going to use the reference angle. Okay, so the sine is going to be opposite. So opposite my reference angle is negative 8 over hypotenuse of 17. So that will be the sine of theta. If I want the cosine of theta, okay, here's my reference angle. I'm just going to look at the reference angle. So it will be adjacent, which is negative 15, over hypotenuse, which is 17. And then my tangent value will be opposite, negative 8, over adjacent, negative 15. Negative divided by negative is positive, so that will be a positive 8/15 for the tangent. All right, and now if I need the other ones, I just do the reciprocal. So the reciprocal of sine is cosecant. So the cosecant of theta would be negative 17/8. The reciprocal of cosine is secant. Okay, so the secant will be negative 17/15. And the reciprocal of tangent is cotangent. So the cotangent will be 15/8. Okay. All right, so the important concepts from this lesson, just to review real quickly. So first of all is, what does it mean to be in standard position? So standard position, the vertex is at the origin and your initial side is on the positive x-axis. Must be that way. If we've got a positive angle, we rotate counterclockwise. If we've got a negative angle, we rotate and clockwise. All right, so next important thing, coterminal angles. If I want to find coterminal angles, I add or subtract 360 degrees as many times as I need to. So I can find an infinite number of coterminal angles. I can just, if I want them to have the same terminal side, I just rotate another 360 degrees. Okay, so to find coterminal angles, you can add or subtract 360 degrees. Okay. Different from reference angles. Reference angles are the acute angles that are made between the terminal side and the x-axis. And reference angles are important to us because those can help us find the trig functions for angles that can't really exist in triangles, right? I can't have a triangle that has whatever this angle that's bigger than 180 degrees is in it. But I can use this, what's called a reference triangle, to still be able to find the sine and cosine and tangent, etc. So those reference angles are very important for finding the trig functions. All right, that is lesson 56. So enjoy working on the problems from this section.